For this video, we're going to talk about curve fitting with linear models. And what we're doing when we're curve fitting with linear models is we're looking at a chunk of data and then trying to see if we can find some sort of linear equation or function to fit or best describe that data. For instance, say we're looking at these three sets of data, one with close points that kind of resemble a line one way or another way, or if they're all just randomly placed around here. And what this is saying is if all these dots are headed kind of in this direction, you can actually pull more or less a straight line going through there that has a positive slope. So we would say it has a positive correlation. And you could say the same thing about this cluster of data, is the data is all heading in that direction, so it has a negative slope or negative correlation. And then looking at this cluster here where they're mixed, I could send a line this way, or this way, or this way, or that way, and it's never really going to fit. So there's really not much correlation at all. Okay, so why are we talking about this? Well, it turns out that we can use this to fit it to any sort of models, and so let's take a quick look at how that can apply to math that we're going to be doing. Okay, so here's a problem. It's a meteorology application, and it's talking about in Akron, Ohio and Wellington, New Zealand, there are about the same distance from the equator. And so we need to make a scatter plot for the temperature data and then identify the correlation and then sketch the line of best fit to find its equation. Okay, so here's our scatter plot that we made right here. And it's nothing fancy. I just took the data points from the months and just drop this information right in here. And what we're going to try and do is figure out correlation, the line of best fit, and then find that equation. Well, the correlation, if I was to put in a blue line here, I would say that it kind of runs right in that general direction, right? And so we can also say that since we're heading downhill, that this has a negative slope, and so that means it has a negative correlation. And if the data were running the other way, in other words, if the data was running like that, then it would be positive slope with a positive correlation. Okay, so what's next? Well, let's see if we can find an equation that fits this data set. It doesn't have to be perfect, and you'll all get slightly different answers. What I'm going to do, though, is I'm going to take this line that I've made, and I'm going to make sure that it's roughly splitting the data points in half. In other words, there's 1, 2, 3, 4, 5 points that are on the upside, and then 1, 2, 3, 4, 5 points on the bottom side, give or take a little bit, but that's about what we're shooting for. Okay, so let's get rid of these numbers. And then what I'm going to do is I'm going to take 2 points, and they don't necessarily have to be on the specifically of the data set. They just have to be somewhere on the line. And this is really handy because what it means is I can use points that are convenient for me. In other words, I can take a point that's right here, and that number is going to be exactly 40 in the x values, and then in the y values it's going to be 65. So that's this point right there. And then I can do the same thing over here where I can grab this point on the line, and that point right there is going to be 75 in the x direction, and then in the y direction it's going to be about 55. Perfect. So now what we have is we have two numbers that we can use to find slope. So we're going to do the good old y1 minus y2 all over x1 minus x2. Okay, what that means is I'm going to take 55 minus 65 and then divide it by 75 minus 40. Okay, so in top I have negative 10, and in the bottom I have, what is that, 35. Right there is my slope, the slope that fits into y equals mx plus b. Just take that point and drop it right into this equation. We're almost there. So the only other thing we need to do is we need to solve for b. Okay, what I'm going to do now is I'm going to take one of these 2 points and I'm going to drop it back into this equation up here. Let's say, well, let's just choose 40 and 65. So I'm going to say 65 equals negative 10 over 35 times, and then my x value is 40 plus b. And then I'm going to do a little bit of shuffling around, and ultimately I'm going to realize, or not realize, I'm going to figure out that b equals 76.42. So my final equation, let's get ourselves a fancy color, let's go with red, is going to be y equals negative 10 over 35, and you could, if you want, you could find the decimal value for that, times x plus 76.42. And it makes sense because this line up here, it's not exactly crossing at 76.42, but we're getting pretty darn close to getting that correlation. This one is the number that I came up with. If you did it and you picked different points, you'd come up with something slightly different too, but we'd all be in about the same ballpark, and that's what we're shooting for.